Hello my dear children, welcome to the science video session. Today you are going to learn the lesson Unit 3 Matter Around Us. Unit 3 Matter Around Us. Matter. Introduction. Matter is everywhere around us. The air we breathe, water we drink, materials we use. For example, the bag you use, the note, the pen, your pencil, your book, everything is made up of matter. So, matter is defined as anything that occupies space and has mass. States of matter. Matter is found in three major states. They are solid, liquid, and gas. So, what is matter made of? Matter is made of atoms. Atoms are the smallest particle of matter. They are so small that you cannot see them with your eyes or even with a standard microscope. So science has come up with a technology to identify structure of atoms by using atomic resolution microscope ARM and tunneling electron microscope TEM, which uses electricity to map atoms. There is more about atoms in the later lessons, but first let's learn about the three states of matter. Matter is made up of group of molecules, and the molecules are made up of group of atoms. Now look into the atom. In atom there are three particles. They are electron, proton and neutron. Electrons are revolving around the nucleus. Proton and neutrons are there in the nucleus. Electron possesses negative charge. Proton possesses positive charge. And for neutron there is no charge. Mass, shape and volume of solids, liquids and gases. Do you need a container to know the shape of a stone? No. Is it? If you move the stone from the ground to a table or place it on the shelf, does its shape changes? No. So, a solid does not need a container. It stays as it is because its particles are tightly packed and has a definite shape. If you take the stone from the ground, place it on the table or shelf, its shape and volume do not change. But what about in liquid? Liquids have any definite shape? No. No definite shape for liquids. They attain the shape of the vessel in which they are kept because the particles have a greater space between them. Particles are not tightly packed or arranged, so they are free to move. What about in gases? Gases have neither a definite shape nor a definite volume. The space between gas particles is greatest. Particles are very loosely packed and arranged. So they takes the volume of container. So solid holds its own shape and its volume is fixed. And liquid, it takes the shape of container and it has a fixed volume. But in gas, it takes the shape of container and the volume of container. Diffusion. Let us come to know about diffusion. Now, place a book on a table. Let it not be disturbed. Observe for 5 minutes. Now take a glass of water and add a drop of ink carefully at the center. Do not shake or stir. Now light an incense stick and keep it in one corner of the room. Let us answer the following questions. Did the book move? Did the ink particles move and spread itself in the water? How long did it take for complete mixing? Did you get the smell of the incense stick from where you are standing? How fast did you get the smell? How did the smell reach you? Yes, we may conclude that the particles of gases and liquids can move easily and quickly. This tendency of particles to spread out in order to occupy the available space is diffusion. Solids are tightly packed and they do not diffuse like liquids or gases. Hence, ink and smoke spread easily while book stays tight on the table. Now we are going to learn that how the particles are arranged in solid, liquid and gas. In solid, the particles are tightly packed with very little space between them. Example, stone. You look at the image of solid. How the particles are arranged as it is tight. Now, look at the image of liquid. How the particles are arranged as in a random manner. They are arranged in a irregular way and the space between the particles is greater than that in solids. Example, water. Now, note the image of gas. The particles in the gases are arranged far apart. They move freely. Example, air. Compressibility of gases compared to liquids and solids. Let us do an activity. Take three identical syringes. Launch the nozzles tightly with a cork. After removing the plunger, first fill it with fine chalk powder. Note the plunger in the given image. Try to press plunger down. What do you observe? Now, let us fill the second one with water. Press the plunger down. What do you observe? Next, take the third one and suck air into the third one. Press the plunger down. What do we observe? Is it easy or hard to press? You would have observed that the plunger moved freely in syringe with air than in water. It was difficult to press and the piston hardly moved in chalk powder. We conclude gases are highly compressible as compared to liquids and solids. So solids are not compressible, liquids are hardly compressible, gases are compressible. Let us summarize the properties of solids, liquids and gases. Solids have definite shape and volume. In liquids, there is no definite shape. Liquids attain the shape of the vessel in which they are kept. Gases have neither a definite shape nor a definite volume. Solids are incompressible. Liquids are compressible to a small extent. Gases are highly compressible. In solid, there is little space between the particles. Particles are tightly packed or arranged. In liquids, particles have a greater space between them. Particles are not tightly packed or arranged. They are free to move. In gases, the space between the gas particle is the greatest. Particles are very loosely packed or arranged. Solid particles attract each other very strongly. But in liquid, the force of attraction between liquid particles is less than solid particles. The force of attraction is least between gaseous particles. Particles of solid cannot move freely. Liquids particles move freely. Gaseous particles are in a continuous and random motion. Matter is classified into two types. One is pure substance, another one is mixture. The pure substance further classified into two types are element and compound. The mixture also further classified into two types, a homogeneous and heterogeneous mixture. There is more about element, compound, homogeneous heterogeneous in the later lessons. Pure substances and mixtures. In shops, we find products which are sold with label 100% pure. For common people, pure means unadulterated. Does not contain any cheap or harmful additives. But for a chemist, the word pure means it's something else. A pure substance is made up of only one kind of particles. Pure substance may be elements or compounds. An element is made up of same kind of atoms. Molecules is the combination of two or more atoms. Compounds in the substance form by the chemical combination of two or more elements. Mixtures is a physical combination of two or more substances. Separation techniques of mixture. First, why do we need separate mixtures? To remove harmful impurities, to extract a component from other components, to obtain a component in highly pure form. First, in the separation of solid liquid mixture, the technique involves are churning, sedimentation, decardation, and filtration. In separation of solids, the techniques involves are handpicking, sieving, winnowing, threshing, and magnetic separation. Separation of mixtures. Let us know mixture briefly. Consider the following examples. We mix rice, dal, salt, chilies, pepper, ghee, and other ingredients to make pongal. Pongal is also an example for mixture. Why do we call these as mixtures? Because they are made of two or more ingredients or components that are physically separable. Air is a mixture because it contains oxygen, nitrogen, carbon dioxide, water vapor, noble gases, and other gases. Milk is also a mixture. It contains water, fat, protein, etc. So, what is a mixture? Mixture is a physical combination of two or more substances. A mixture need not have a fixed proportion of components. So, the process by which the components of mixture are isolated and removed from each other to get pure substance is called separation. To know the original properties and use the individual substance, we need separation. Now we are going to see some simple methods of separating substances. They are handpicking, threshing, winnowing, sieving, churning, filtering, and magnetic separation. Filtering. The choice of method of separation depends upon the properties of the components of the mixture. The separation method may be based on the particle size, shape, or physical state. They may be solids, liquids, or gases. Now come to the filtering. You may have noted that your mother uses a strainer or filter to remove the tea leaves to get the clear liquid. Larger sized particles of tea leaves will be retained by the strainer while the clear liquid will passes through. This is called filtering. Sieving. A sieve is similar to a strainer. Sieving is used when we have to separate solid particles of different sizes. Example, sand from gravel. Sieving can also be used to separate substances that don't dissolve in the liquid. Sieving only works for separating insoluble substances from the other substances. Churning. When very fine insoluble solids have to be separated from a liquid, as in butter from curd, churning is performed. The mixture is churned vigorously when solid butter will be collected on the sides of the vessel. Both butter and buttermilk are obtained after churning are useful and can be consumed. Threshing. When we pluck flowers from plants, we are separating the flowers from their stalks. Can we do the same for food grains like rice and wheat? It is not possible because the grains are small in size and also the quantity is very large. Farmers separate grains from their stalks by beating them hard. The grain are separated from their stalks. This is called threshing. Winnowing. It is an agricultural method for separating grain from husk. Rice, wheat, and other food grains are covered in husk which cannot be eaten by us. Husk is very light and gets easily blown away by a breeze or wind. This method is winnowing. This is done by dropping the mixture slowly from a height in the presence of wind. Lighter solids, that is, husk, will be carried by wind and will be collected in a separate heap, while heavier solids, that is, grains, will fall closer and form a separate heap. The next method, hand picking. If the rice that we cook has stones in it, we have to pick the stones out, isn't it? So, how do we identify a stone from a grain of rice? If the stones are visible, different from the grain, they can be easily picked and separated by hand. This is hand picking. But if the stones look very similar to the rice, it is difficult to separate. Magnetic separation. In a mixture containing iron, the magnetic property of iron can be used to separate it from non magnetic substances by using a magnet. Substances that are attracted to a magnet are called magnetic. Separating solids using a magnet is called magnetic separation. Sedimentation. Rice and pulses are often mixed with very fine straw, husk, or dust particles, which have to be removed before cooking. Are you familiar with the way this is done at home? The lighter impurities float while heavier rice grains sink to the bottom. This is called sedimentation. So, the settling down of heavier components of a mixture when allowed to remain undisturbed for some time is called sedimentation. Decantation. This process is done after sedimentation. The process of separating liquid above the sediment by using glass rod is called decantation. Filtration. The method of separating insoluble components from a mixture using a filter paper is called filtration. So, how to fold the filter paper and use it? The folding of filter paper is shown in the picture. The first fold A, the second fold B, the third fold shown in C, and make it as cone and place it in a funnel. In this process, the mixture is slowly poured over the filter paper. On filtration, clear water flows down the funnel and mud settles as residue on the filter paper. The liquid which passes through the filter and comes down is called filtrate, and the insoluble component left behind on the filter paper is called residue. Food adulteration. Sometimes things that we buy in the market are mixed with harmful and unwanted substances. This process is called adulteration. Food can also get adulterated due to carelessness or lack of proper handling. We must be careful about the common adulterants in our consumable goods, especially in food. Any adulterated food, when consumed, will be harmful and can be a health hazard. See, for example, in tea, they are mixing the used tea leaves. This is causing liver disorder. In milk, they are adulterating unhygienic water and starch. This causing stomach disorder. In edible oils, they are using unedible oils. This is carcinogenic. Carcinogenic means causing cancer. In turmeric powder, they are adulterating lead chromate. This causing liver disorder.